Okay, calculus, we are here looking at AB 42, derivatives of inverse functions. So this is really kind of like the big idea here is a lot in this prompt itself. There's going to be a prompt that you might see on an AP test or some type of other calculus exercise where it says find the derivative of the inverse of something at x equals something. This is a pretty common prompt here. So let's see how we would attack it. There's a couple of strategies, and honestly, in your workbooks, it has some things here. And this first or the second method is probably the more common one that we're going to be looking at. So I'm going to be doing that one mostly. Let's see. Yep, that's probably mostly what we're going to be looking at. But let's take a look at what we can do. So method one, if we're trying to figure out this derivative and we can somehow get the value of x by solving for y, all this other junk, there's a lot of things you can do here. But if we were to do this with a different example, like the ones that you guys have later, let's jump ahead. Let's go way ahead, all the way to these. Here we go. Alright, so let's say I wanted to do A. I want to find the derivative of the inverse function. And the general idea with inverse function here is you're just going to switch x and y. That's it. And then find the derivative at that point. So here's kind of our problem. We say that y equals x cubed. So first we got to switch that. It's going to be x equals y cubed plus 1, of course, right there. Then we got to take this derivative implicitly. So we're taking the derivative with respect to x all the way across. That would be 1 equals 3y squared dy dx. Cool. So that's it. No big deal, right? Okay, so we put this back over here, and we would say 1 over 3y squared equals dy dx. No problem. So we just found the derivative. And now we just got to plug in a number. Well, we know x equals 9, but we don't know what y equals. And that's kind of the hard part. So this is where it gets, a little more tricky. And what we see is this original inverse function that we came up with. And in that inverse function, we know that, let's take this down the bottom here, we have x equals y cubed plus 1, and we know that x equals 9. So I'm going to say 9 equals y cubed plus 1, subtract 1, subtract 1, and 8 equals y cubed, so taking that all the way through, y equals 2. So wait, y equals 2. What am I going to do with that? I'm going to plug it in to the y that I need right there. So I put this together. I'm going to put dy dx at x equals 9, which means y equals 2. Now we're going to plug that in here. So we have 1 over 3y squared, but the y value is 2, so it's going to be 3 times 2 squared, which altogether that's going to be 1 over 12. That really wasn't that bad at all. I mean, I look at that and I was like, oh, well, okay, is that it? I guess. Cool. Check. Let's try another one. In fact, you know what? Just for space sake, let's do these on different slides. So I'm going to take this one. We're going to do this one on a new slide. I think it's going to jump me right there. There we go. And we're going to do this one here on a new slide as well. Perfect. So there we go. So let's kind of go through this same process. First, we got to switch x and y because it's asking for the derivative of the inverse. Well, the inverse function means we switched x and y. So x equals y cubed plus 5y minus 1. No problem, right? Now take a derivative all the way across. We got 1 equals 3y squared dy dx plus 5 dy dx Alright, so now we got to simplify things a little bit here. That's going to give us 1 equals 3y squared plus 5 all times dy dx. If we factor that out, then we can divide both sides by 3y squared plus 5. And now that we're at this point, we know that 1 over 3y squared plus 5 equals dy dx. No big deal, right? Well, we know that x equals 5. Okay, so x equals 5. Let's see how that would work into our inverse equation here. That would mean that 5 equals y cubed plus 5y minus 1. Okay, not a huge deal. Let's see if we can maybe go a little bit further here. Now I actually see a way to kind of factor this and do some general problem solving. You could do this just through graphing, but I want to show you guys something kind of interesting here. If I add 1 to both sides, that makes this side 6. I could factor the y out over here on the other side and then give me y times y squared plus 5. Now if I'm trying to think about what numbers multiply to 6, well there's a couple options. You know, we got 2 times 3 or 1 times 6. And if 2 was y, well then 2 squared plus 5 would be 9, and 2 times 9 is way too big. And if 3 was y, this would be way too big also. But if this was 1 times 1 squared plus 5, that equals 6. So y must equal 1. Now that's kind of some backwards problem solving. So let's show you a way to back that up and see if you could come up with the same answers. So I'm going to go to my equations here on my graphing calculator, and I'm going to type into it y cubed. So we got, well, not y, we got x actually, because we don't have y, but our variable x cubed plus 5x minus 1, and then I'm also going to graph the number 5, not 55, just 5. And for my zoom, let's do zoom standard. Alright, so we definitely have an intersection here. We're trying to figure out what's the value, and in this case it's x, even though that's really y, but we're trying to figure out when do those intersect. At what value do those intersect? We know that here's the number 5, and when does this function hit the number 5? So to calculate that, I can do second calculate intersect. I got to get close to it, so I'm going to follow this curve. Looks like about there, there, there. And it's happening at 1, 5. So the answer is 1. Even though this says x equals 1, y equals 5, it's kind of like working this whole thing backwards. So we knew that x equaled 5 here. We tried to figure out what is the variable of this other thing. Well, we can't plug in y into our calculator per se, so we had to use the x. But it's just solving when an equation equals a number. And we figured out the answer is 1. Wait, so what do we do with that? Alright, let's do third stage here now. So dy dx equals 1 over 3y squared plus 5. But we know that y equals 1. So this is going to be 3 plus 5 over underneath 1, which equals 1/8. So there's a slope. That's it. Check, check, done. Let's do another one. These are fun. Actually, I'm probably going to do some from the homework too. I'm going to pause it right here in the middle after we finish this one, and then we'll get that done as well. Okay, so y equals x plus sine x. Remember, we're doing derivative of the inverse. And when that's the case, let's go ahead and switch. X equals y plus sine y. Alright, now let's do implicit derivative. That means y equal, or 1 equals 1 plus cosine y dy dx times both of these. Because each of those had a dy dx. I have one from the first one and from the second one. Okay, so then I have to figure out 1 over 1 plus cosine y equals dy dx. That's what we're at. So we know x equals pi. So if x equals pi, and that means that pi equals y plus sine y, we got to figure out when those would be equal to each other. Well, let's see if we can calculate it. So the constant that we're trying to get equal to would be second pi right here. And our equation that we're trying to equal to that is the variable plus sine of the variable. We don't need any of these other buttons. Close it off. All right, there we go. Let's graph them. And it looks like we're right about here. So let's solve for that intersection. Second, calculate intersect, which is number 5. Now I got to scroll over. That looks pretty close. Let's see how that goes. Alright, so we are doing enter, guess. And it says, oh, this is interesting. Take a look at this. The value that we're trying to equal is pi, and the point at which that happens is also pi. So y equals pi. So let's see what would happen here then. If I'm looking at this function, we got 1 over 1 plus cosine of pi. Now this is the crazy thing. Something crazy is about to happen here. You guys are going to see it. What's cosine of pi? It's really -1. So this is 1 over 1 plus -1, which would be 1 over 0, but that's really undefined because the denominator equals 0. So what do you call like an undefined slope like that? When you have like a number over 0 kind of thing, that actually becomes a vertical tangent. We have a line going vertical at that point, which could happen. You know, it does happen. It's kind of crazy, but that's what would have happened. Who knew? So let's now, I'm going to pause the video here, and I'm going to do some more examples from the homework, just to give you guys kind of a head start into that. All right, and we're back. We're finding the derivatives of the inverse functions. So let's do that. First, I look at this and I see f of x equals x cubed plus 2x minus 1. That's like saying y equals x cubed plus 2x minus 1. So if I were to switch those, because that's what an inverse function does, x equals y cubed plus 2y minus 1, then I got to take the derivative of this. Okay, so let's do that. If I were to take the derivative, that would mean that I have 1 equals 3y squared dy dx plus 2 dy dx, and then that third term here goes to 0. Okay, so now that I have this, let's do some factoring. We would have 3y squared plus 2 times dy dx equals 1. Then divide both sides by 3y squared plus 2. And that gives me 1 over 3y squared plus 2 equals dy dx. Alright, at this point, I notice I need to plug in y. However, we have x. So how do I find y when I know x? Well, here's x, here's y's. Let's calculate them. So we know that x equals 2. So 2 equals y cubed plus 2y minus 1. So let's do a couple things here. The first thing that I see is I'm going to add 1 to both sides. Then I'd get 3 equals y cubed plus 2y. Then I could factor out a y, and I'd have y squared plus 2 equals 3. Well, I know to multiply 3, if there's a simple answer to this, and I'm pretty sure there is, because this one could be done by hand, that means it should be 1 times 3. Well, that could be like 1 times 3, and the only way that would work is if y equals 1. And then 1 squared plus 2, that's 3. So y must equal 1. And if I were to do this with a calculator, if I were to do some factoring, I could figure that out. But some quick problem solving actually, got us to that point. So y equals 1, what do I do with that? I plug it in right here. So what's dy dx? dy dx is going to be equal to 1 over 3 times 1 squared plus 2. Simplify it even more. You get 1 over 3 plus 2 is 5. There's my slope. dy dx is 1 over 5. 1 over 5. Let's do another one. Pick a color, any color. How about orange? Not orange. How about this color? What's this color? Green? Brownish? What is that? Who knows? Okay, so we have y equals sine of x. Ouch. This one's going to hurt. Well, no, not really. Actually, yeah, it'll be fine. It'll be fine. So first thing we got to do is switch the x and y. So let's do that. Sine of, or x, pardon me, if I'm going to keep this kind of consistent here. X equals sine of y. Now I got to take the derivative of those. So let's do that. We take the derivative, and that gives me 1 equals cosine y dy dx. And then I need to get this dy dx by itself, so I divide both sides by cosine y. That gives me 1 over cosine y equals dy dx, which is excellent, but I got to plug in y, but all I know is that x equals 1/2. Now I'm not sure if this is saying, this kind of looks like it's saying at x equals 1/2, at x equals 2. I'm not sure what's going on with this 2 business here with the parentheses. So I'm going to take the easy way out and pretend it's not there. So that's gone. Let's just look for x equals 1/2. So when x equals 1/2, so that would be over here, 1/2 equals sine of y. For x to be 1/2, no, honestly, you don't need to know unit circle for this, and this is kind of the crazy thing because it's asking us to find cosine of y, which means we could just use right triangles, and that's it. But let's use some right triangles, or let's just use some math here anyway. So if sine of y equals 1/2, that would happen when y equals, what would we get there? 1/2, that's y equals pi over 6. At pi over 6, sine would be 1/2. Now if I didn't know that, if I didn't have that insight, you can also consider sine to be SOHCAHTOA, and if we're talking about the SO group, SOH, that means this is the opposite and this is the hypotenuse. So if I were to draw my triangle, my opposite would be 1, my hypotenuse would be 2, and then down here, this other side would be square root of 3 using Pythagorean theorem. Here's my theta. Or it's actually not theta, it's y, because that's the angle that we're plugging in. So this is y. So over here, when I say 1 over cosine y equals dy dx, This is where it gets interesting. I could think, what's cosine pi over 6? Well, guess what? Here is a triangle that has pi over 6. I didn't even need to know what y was. I could have just used some right triangle magic. So 1 over cosine y. Cosine y is really the adjacent side over the hypotenuse side. So that's square root of 3 over 2 equals dy dx. So simplifying it all the way, you know, flip this, multiply, you get 2 over square root of 3 equals dy dx. And for those old fuddy-duddies that like to rationalize square roots in the denominator, because for some reason they still use slide rules, even though we're in a world of calculators, you would multiply by square root of 3 over 3, you get 2 root 3 over 2 equals dy dx. Check. Too easy. Let's keep going. Number 5, Johnny 5. Okay, so we got y equals x cubed minus 4 over x. Not a huge deal. Let's switch x and y. That would give me x equals y cubed. Now to take a derivative, I'm going to change this second term here to minus 4 times x to the negative 1. That'll make it a little bit easier when I start to take the derivative. D dx is what I'm about to do. Okay, so now I'm going to take the derivative, and that means that I would have 1 on the left side, because the derivative of x with respect to x is just 1. And the derivative of y cubed is going to be 3y squared dy dx. And the derivative of the second term, a little bit more complex. The negative 1 drops down, and we still have the minus, so it's like minus 4x. Then we subtract 1 from that power, makes it negative 2. So this is really, and this is our, whoa, what are we doing? That's not an x. Goodness gracious. This should be a y, this should be a y, which means I took the derivative of y. It means I need a dy dx. There we go. Alright, so now put it all together. We got 3y squared plus, now this, because that's minus minus, that's really plus, 4, and then y to the negative 2 means over y squared. All of that times dy dx. 1 over this, so that's 1 over 3y squared plus 4 over y squared equals dy dx. Excellent. Okay, so we're there. We've gotten there. All we gotta do is plug in y, right? Oh, but wait a second. Darn, they just gave us x. How do we figure out y when we have x? You plug it in. So x equals 6. Then we got to figure out y. 3y, or y cubed minus 4 over y. This is just crazy. What could we do there? Well, here's a couple things. X is greater than 0 here, which means we can't really divide by 0 there. I don't know if y is greater than 0, but that would not make much sense in solving this equation. So I'm going to multiply everything by y. Let's see what would happen, just to get rid of that y in the bottom. I'd have 6y equals y to the 4th minus 4. Then if I were to subtract this 6y over here and add the 4 over here, let's see what that would do. That would give me 4 equals y to the 4th minus 6y. Now let's factor this. I'd have y times y cubed minus 6 equals 4. So now I have a couple of factors multiplied equal to 4. Let's figure out how we can multiply to 4, and let's see if we can work our way around to that. Okay, so 4 is either 1 times 4 or 2 times 2. Well, if this was 1 times 1 cubed minus 6, that would be not very big at all. 1 times 1 minus 6 is really negative 5, so that doesn't work. What if it was 4? 4 times 4 cubed minus 6. That's huge. 4 cubed is like, what's that, like 64 maybe? Okay, so that's big. Way too big. Let's try 2. 2 times 2 cubed minus 6. That works perfectly. 2 times 8 minus 6, which equals 2 times 2, which equals 4. So y equals 2. So over here, now I got to simplify. This is going to become, I'm going to plug this in, into this y and this y. That gives me 1 over 3 times 2 squared plus 4 over 2 squared equals dy dx. Technically, we're done. But simplifying, let's go ahead and do it just for fun. 3 times 2 squared. 2 squared is 4 times 3 is 12. 4 over 4 is 1. So this is 1/13. That is our derivative dy dx of the inverse, of course. Too easy. Too easy. Alright, 7. How many more do we have? Just this one and the next one. I do believe this is going to require some calculator usage. So, just an FYI there. Let's see what we got. So this starts out as y equals x cubed minus 2x squared plus 5x minus 1. Alright, not too bad. Let's switch them. Then we got y cubed minus 2y squared plus 5y minus 1. Now we take this derivative, we get 1 on this side. On the other side we got all this stuff that's going to be times dy dx. So let's go ahead and factor out that dy dx. Because all of them get a dy dx since they're all terms of y. We got 3y squared minus 4y plus 5. Okay, now I'm guessing that this is not easily factorable up here, which is why we're going to have to use a calculator. So let's go ahead and get as far as we can. So we got 1 over 3y squared minus 4y plus 5. So our dy dx in the end equals 1 over 3y squared minus 4y plus 5. Alright, not too big a deal. We're kind of working our way through here, but we have that. We know that x equals 2. We also know that x equals y cubed minus 2y squared plus 5y minus 1. So we got to figure out, when does 2 equal y cubed minus 2y squared plus 5y minus 1. So that means we got to go into our calculator and do some magic. So my constant function I'm trying to equal to is 2. Let's see what I'm trying to do with the other function here. It's y cubed, so we just got to use the variable x in this case, because that's what we have. X cubed minus 2x squared plus 5x minus 1. Now don't get confused just because it says x's. We can't use y's. We're just trying to solve an equation. So if we go to our graphing and solve where these cross each other, I think we're going to find an answer. Yes, we are. Oh, yes, we are. Check that out. It's right there. It looks like just below 1. So second, calculate. Intersect is number 5. So I'm going to scroll to the right just a little bit more. It's too far. Well, who cares? Close enough. Close, close. You click it 3 times. And there's our intersection. Okay, so I'm going to pull this over here for a second, and let's just kind of talk about it. So we know that this kind of says it backwards, like y equals 2, x equals this big long thing. So really this is the number that I want to evaluate this other thing at. So this is going to be 1 over, is that a 0.7? I think it is. 1 over 3 times 0.7372 squared minus 4 times 0.7372 plus 5. So I got to calculate that. Good thing I have a calculator. So let's clear this, clear this. So I'm going to do 1 divided by, now I got a bunch of stuff down here. What is it? What all is it? 3 times 0.7372 squared minus 4 times 0.7372 plus 5. So all that's in my denominator. There we go. Calculate it. 0.2716. So this equals 0.2716. Excellent, excellent, Excellent. Okay, last one for the night. I know this is kind of longer video than expected, but hey, I did some of the homework problems for you. You should be happy. Alright, so we got y equals x over 2 plus sine of x quantity squared. Why did I do that? Well, because we're going to take a derivative and it might be helpful later. So I'm going to first switch x and y. X equals y over 2 plus sine of x squared. So take the derivative. We got 1 on this side. And now we're going to have y over 2. That's really 1/2 times dy dx. Plus, now there's a chain rule. Notice outside, inside. The outside is going to be 2 times something to the first power. The inside is sine of x the first time. And the second time it's cosine of x, which is the derivative of the inside. And all of that, whoa, craziness. This is sine y, which means this is sine y, and this is cosine y. Details, Mr. Butler, details. And I was just thinking, this is what caught me on that. It's because I'm supposed to have a dy dx here, because I just took the derivative of y, so I'm going to multiply all that by dy dx as well. Okay, so factor out the dy dx, and what do you got? We have 1/2 plus 2 sine y times cosine y, all times dy dx. So I got to divide by that on both sides. 1/2 plus 2 sine y cosine y. Over here is going to be 1/2 plus 2 sine y plus cosine, or not plus, times cosine y. Oh, that's a mess. Okay, so let's rewrite it up here all from scratch. Dy dx equals 1 over 1/2 plus 2 cosine y, not cosine, what did we start with? Sine y cosine y. Excellent. Okay, so we know that x equals 3, but the crazy thing is, what is y? Because that's what I have to plug in. So how do I calculate this again? Well, back here, I got to solve it. If I know that 3 equals y over 2 plus sine of y squared, I got to figure out what y equals. So I got to graph those functions and see where they intersect. So y is going to, or x is 3. In this case, we should say like y equals 3. But let's calculate this other one. It's going to be the variable divided by 2 plus, okay, now we got to put this in parentheses, sine of the variable, close that all off, and then square it. Delete these other two pieces, and there we go. So let's graph it. Well, that's kind of interesting. When does it happen? Looks like it happens right about there. So let's second calculate this beast. Number 5, rolling over here. Where is that? Any guesses? Who wants to guess? I'm going to guess, I don't know. I don't have a guess. My guess is at 4.3086. So over here, y equals 4.3086. Check. So that's the answer. Y equals 4.3086. Wait, that's not the answer. That's what we have to plug in to these values. Oh, okay. Now, you guys might be thinking, oh, I got to calculate all that. Think about this for a second. I'm going to go in here and I'm going to turn off something. I'm going to turn off this value. There. Okay, so I turned off 3. Now, I have this function in here, and I could plug in a number and calculate a value. In fact, you can do that from the second calculate part of this function. So this is the function, right? No, it's not. It's this one up here. It's the derivative. Pardon me. Let's turn this off. Turn that off. You know what? And I'm going to clear this graph. Clear. We're just going to calculate it. It's the derivative. It's this piece up here. So I got to do 1 plus, or not 1 divided by, now a big huge denominator. We got 1/2 plus 2 sine of that crazy number, 4.3086, times cosine of that number, 4.3086. We've got to close all that off. There we go. 0.8179. So dy dx equals 0.8179. Check. Now we're done. Wasn't that fun? Okay, remember, go back and check these videos so you can use them on your assessment and also as review resources for studying long term as well. Have a good night, and we will see you in the next class.